Okay. This time what I'm gonna try is to solve medium level problem with with some acceptance rate below 75 with a high frequency. This seems to be interesting. Subdomain visit count. Let's try this. Subdomain visit count. Carrot, Palantir Technology, Intuit, Indeed, Walmart, Wayfair, Roblox. Let's solve something else with some big company name. Maximum difference between node and ancestor tree question. Amazon, Facebook, Google. And how about this? Subsets. Bloomberg, Amazon, Facebook. Oops. Facebook loves this problem. Wow, this seems to be very popular problem. Okay, let's try this. Subsets. Subset. Given a integer array nums or of unique, let's start the timer, of unique element, integer array, unique element, return all possible subsets. The power set. The solution. This is the question I don't like, actually. The solution set must not contain duplicate subset. Return the solution in any order. 1, 2, 3. Subset 1, 2, 3. So here subset is like 1, 2, 3, right? So if we visit 1, then next time we can visit 2 and 3. If we visit 2, next time we can visit 3. And if we visit 3, next time we can visit 2. And in case of 2, we already visit 1, so this time we can visit 3, right? And then here, so this actually means that 1, but this is not the subtree. Yeah. And then we can also do this, but for this 1, after selecting 2, 1 is not the right answer, 2 is not the right answer, so we go 3. So likewise, here 1 is not the right, 2 is not the right, so we go 3. Right? And here 1, 2, 3x. Something like that. So 1, oh. And then we have this too. I mean empty. Yeah, empty. So here 1x. Okay. From here so anyway, it seems like this is some kind of backtracking. So backtrack nums, and then we need yeah, so what I'm gonna do is I'm gonna write some backtrack method, and then I'm gonna add the result. So so for example, from here we can loop this, and then inside this loop we can loop this again, right? So here we found 1, so we can loop again, and then for 1 it's in the result, so we are not going to add this. 2, I mean from this path, I'm talking about this path. 2, yes, it's okay. 3, yes, it's okay. And from 2, no, no, yes. So we're gonna have this path. And from 3, everything is no. So we need to go back. So this is one way to solve this. And the problem here is, how do we know and then the thing is, in this case, how can it generate with this? So backtrack might not the right way to solve this. In case of backtrack, we generates all the combination, but not the subset. So how can it generate those? One possible way is, well, in this path, this one, and then this one, you can stop. And then, well, this one, or we can stop here. Let's do this. Let's not use the backtrack, but let's say that this is empty, and 1, 2, 3, and the next time for empty we can also include empty. So in this case we stop. So empty we include 1, then next time we do this, then we stop. And in case of 1 we already have, so we just continue to the next, which is this one. So we include this, and here, so 1, 2, 3, and then stop. Then this one, this one, this one, this one, then one more level, here, stop. Then this one, this one, this one, and this one is the last one, so stop. So I guess we can generate things like this. But in this case, for example, from here, it needs to go through all of this. Okay, so 4 here, and it needs to go through this and this. And then in this case, for 2, it can go through this and this. So it's not backtrack, but let's say that recursive. Let's do the recursive. So for vector int result, for this one, for int initially we can put the this empty set, then k is 0, k is nums size, and then the thing is, yeah, this is not sorted array, but now here we know that let's start from 0. So initially this will start like this, and then generate recursively. What we can do is from so k plus 1. So if k is less than minus 1, result. So this means that from k so what's the meaning of gen recursive? Gen recursive from start. So it means that this guy will add that this guy will generate all the case from start, right? So which means that if we give it to number 1, index 1, then we will generate 2, 3, 2, 3, and also empty. So that will be, so and then in case of 1, it will add this, this one and 1. Yeah, so the last one, get subset. So we'll get this. Or get subset. And then so 1, 2, 3. We'll get 3 or empty. 2. We'll get 2 empty, 2 empty. 1 empty, 1 empty, 1 empty, 1 empty. So here we'll have 1, 2, 3, and then 2, 3, and then 1, 3, and then 3. Here 1, 2, and then 2, and then 1, and then 1, 2. 1, 2. 1, 2, 3, 2, 3, 1, 3, and then 3, then 1, 2, and then 2, and then, oh, this is 2. The 1, the 1, yeah, so this is the way. And then the problem is how to generate these sets. So let's say if the start is nums the size -1. So this is the last one. So in that case, we can return nums start, and this is the one, and this is another, right? And the color of this one, which has start nums size -2, need to duplicate this, else gen recurse num k +1, not k, +1, and then res. I don't know how I can use res, but we can do this. So actually, let's say this. So what we need to do is something like clone, right? And then append, and then as to and place back nums start, and then return as plus as 2, something like this. Actually, we can make clone here, and then what I don't know is how to copy answer 1 into answer 2, or how to move effectively. I don't know. So if n's that size, say this is n's that size, and then and then copy ans 2 begin ans 2 into ans plus n. So we'll have ans which have the attached form, something like this. But this needs a lot of copy, which I don't like. Return get subset. So we don't need this. This should be 0. So for easy, nums dot size 1. There's no 0 case. Return nums vector int no. We can return this, right? Else get subset num 0. So this is not actually true. This is true, right? So when so there are some test cases here. So so the list is 1, for example, like 100, like 10. So here start is 0, which is the same as this, so we just return this. So we return num start, which is 0, so 10, and then this. We return this. And let's say 5 and 10. In this case, we call this. So start 1 is now 1. So ans will be something like this, right? And here ans 2 have the same thing. So let's say that this is ans and this is ans 2. And then we add this, which is 5 in here. So this is not in place back. This is like a for each ans to begin and int, no, not int, vector int v dot in place back. Right? So which means we will add 5 and 5 here. And then here ans dot size is 2, so we increase the size into 4. So there's something which is garbage. and then we're gonna copy this into here, right? So this is the answer. We return this. Yeah, I guess this is the answer. What is the start get subset nums return value is different. $16. No conversion. Okay. 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 About this, because this is initializer list. Maybe this will work. Around scalar, whatever. Genericer. Order v equals this, then v dot in place back. Not sure this will work. And v empty candidate template ignored, so this does not know vector int. And then for each variable, nums cannot be implicitly captured in the lambda. Nums, okay. So we need to do something like this. And then start. I guess we also need start. Start is just an integer, so we can just pass by value. Okay, so here some v, maybe ans will be better. Wrong answer. Okay, 1, 2, 3. Let's say 0, 1, 2. So from here we'll get plus 1. So this will be called until it gets to the last 1. So start now 0, 1, 2 is 2. Yeah, so here initially we have empty one, and then we have this. So I'm not sure. Assert 2. This one failed. Seems like this size is not. Okay. Okay. So now so this copy sends 2. Right? What did I do? What did I do? Right? Right? Oh, okay, I understand. So here, yeah, because previously it was already increased by 2, doubled, and then ans2 is now doubled too. So this is not actually true. Okay. Okay, so 2, 3, 4. 1, 2, 3, 4. Yeah. So somehow, when star is 1, it will get this vector, and then this num start, and then we copy and then add num start into here. Okay. Okay, so it's done. But it seems like the speed is not very good. Oops, someone is very good. Memory wise, yeah. So one thing I can increase the speed. Speed seems okay compared to other solution. And then some improvement. How can I make some improvement? Let's remove this. Well, probably this will be compiled with some optimization on. I don't know. Or maybe I can use some iterative way. How can I make this iterative, write this in with iterative way? So one way of doing this is that starting from 3, we can make some vector of MT and 3, and then that vector set is given to the next loop, and in the next loop the vector is copied, and then we can add 2 into the half of the vector. So that might be one of the way we can implement this. I don't know. Well, let's see the solution. Solution pattern. Let us first review the problem of a permutation combination subset, since they are quite similar to each other and there are some common strategies to solve them. Anyway, it took me like 35 minutes to solve this question. It's kind of not very satisfactory time. Satisfying time. Because I should solve this within 20 minutes. And one of the problem I have is that I sometimes thinking too much about backtracking. So I probably need to learn about backtracking a little bit more. Backtracking is like, okay, try next. Oh, this is not. Let's go back. That is some kind of backtracking. And in this case, it can be solved with backtracking, but the decision to make, oh, it is not, is kind of tricky. Because to decide that, we need to decide that and then one of the difficult part is empty set. So previously when I tried to solve this with backtracking, I was thinking that meeting empty set means end, the end, right? That might work, but I am not sure. But one obvious problem with backtracking is that it takes some time because it needs to try some cases that is actually not the answer. Yeah. Maybe I need to see the backtracking again. But permutation and how can I read? And exclamation.
N.
Are you kidding me? Combination, permutation. Permutation. For permutation is a set, loosely speaking, arrangement of its members into sequence or linear order. Each of 6 rows is a different permutation of 3 distinct bulbs. And combination. Distinct member. Three-element subset of 3. Yeah. Combination. Subset. Hence each element could be absent or present. 2 to the power of n. Yeah. 2 to the 2 to the power of n. Subset is 2 to the power of n, of course. So given their exponential solution space, it's tricky to ensure that the generated solutions are complete or non-redundant. It's essential to have a clear and easy-to-reason strategy. There are generally 3 strategies to do it: recursion, backtracking, lexicographic generation based on the mapping between binary bit mask. Lexicographic generation based on the mapping between binary bit mask and the corresponding permutation. Oh, sounds really fancy. As one would see later, the third method could be a good candidate for the interview because it simplifies the problem to the generation of binary number. Therefore, it is easy to implement and verify no solution is missing. Besides, as a bonus, it generates lexicographically sorted output for the sorted input. Lexicographically generated lexicographic generation. Binary bitmap. Okay, so that's cascading, backtracking. Oh, backtracking is one of the way to solve lexicographic subset. So what I tried was cascading. Start from empty subset. Start from empty subset. Take one into consideration. And add two subset by updating existing ones. Take two into consideration and add two subset. Yeah, this is basically what I did. The order was different because I did from the end and it did from the beginning. So that is the difference. And for num, new array list for output array list output new subset add num. It also copied. Yeah. Maybe instead of copying, I don't know, because for int k is 0, k is 2 dot size k plus plus, and then int 2, we can swap int 2 k and s plus n and k. So what will happen in this case? I don't know. use backtracking. Okay, backtracking. Power set is all possible combinations of all possible length. Length 0, length 1, length 2, 3. Given the definition, power set is all possible the problem can also be interpreted as finding power set from length equals the length of combination rather than the candidate number. Generate all combination all subset of length 0. Backtracking is an algorithm for finding all solution by exploring all potential candidate. Solution candidate turns to be not a solution. Backtrack algorithm discarded by making some changes in the previous step. Iterate over all possible lengths from backtracking. Generate all possible subset of length 2. So this is a specific case for length 2. So num 1 to 3. Take num 1 at the first element. Use next element num 1 and num 2 to complete the section. Use 2. The subset is complete. Backtrack. Pop num 1 out. Use num 2. What is this num 2? Should be num 1, right? And why is this backtrack? We define a backtrack function named backtrack, which take the index of first element to add and the current combination of argument. Current combination is done. Otherwise, we iterate over the index I from the first to the length of the sequence n. Okay, add the integer num I into the current combination cur. Process to add more integer into the combination. Backtrack by removing cur. Oh, Python is too short. Okay, backtrack. Output empty. Then length num k in range backtrack. So backtrack first. Current is length of current. What is current? Oh, the current is set. Length of current is k. If length of current is k. and then it just return. K, what is K? Does this work? K is in here, and then it is not passed to backtrack. But here we use K. I don't know. Backtrack is here, subset, backtrack first, and then array, and then nums from 0. So K is this one. So if current size is K, I'll put current. If K is 0 and current is 0 initially, current size is this size, so input the empty one and return. If K is 1, and this is new, K is 1, current size is not, so K is the length. So what it does is that I start from 0 to n. What's n? Num length. Current add num. Removable. Wow. So it has some kind of output, and then it has some kind of current list. So adding something into current, and then try to backtrack. So if the list is 1, 2, it starts from the length is 0, 1, and 2. In case 0, empty is returned. In case of 1, it will call, it will add num I, which is initially 0. So the list is 1, 2, so 1 is added into there, and then At the end it is removed, and then 2 will be added, right? So when 1 is added, it will backtrack from 2. So inside backtrack, it will, so this is a output array list current. So it will add 1. Then if num is 2, I mean I is for 2 in num. Okay, in case of, if k is 2, here 0, 1, 0, 1, 2. Okay, if k is 2, what it does is it tries to add 1, and then backtrack will code with 2, so it will add 2, and then backtrack, which will return empty. So it will return, then 2 is removed and 1 is removed. Yeah. Let's say there is 1, 2, 3, and then we are looking for a combination of 2. So first 1 is added, and then 2 is added. In the next turn, 2 is added, and then return. Okay. The next turn, 2 is added, and then it will try to find the 3. Okay. Yeah, I understand. But understanding and writing the code is pretty different problem. And then how can I know whether the backtrack is for the length? Is it really easy to think about? Lexicographic binary sorted subset. Oh, this is from Donald Knuth. The idea is that we map each subset to a bit mask of length n, where n is on the ith position in bit mask. So bit mask, this subset is empty. Yeah, I understand. So the question is, how do we make this combination? Oh, so we can loop. Oh. So and then in this case we need to, so we can divide. How do we know that 3, we have to add only 3? So we need a loop. Then if this is bigger than 8, then we can define that one will need to be added. And after doing that, or we can shift to the right to get 3. So what? Binary string? What is binary string? Bin? Bin? What is bin? Map a subset to each bit mask. Substring 1. Integer append the subset corresponding to that bit mask. URI list. Bmask character I. This is the loop. numj character at. So this is some kind of string. And then you check the string. Not sure whether this is a good thing to do, because by shifting it, we can get the number. Maybe I can write that, but I spent too much time, so let me finish here. Well, this is not a bad idea. I think the third one is pretty good one. This one is pretty good. And then in case of third one, let's think about how to populate the set, the vector. So let me try to write. Okay, so here bit mask. So int for k equals 0 is to the power of so if this is the input, power to 2, this is 4, so 1 2 3, so this is correct. So we have to loop inside here, and then we'll have some answer. And the size of answer is actually power to this one, right? So size 0, not 0, size let's not do this. Okay, so what I can do is that these are all the cases, right? So count and then empty vector. Does it work? So I'm gonna have reference to answer k, and then what you need to do is that if kth bit is 1, so for int t is 0 to t is num dot size t plus plus t so if k and 1 if this is true, so let's do int. Let's do this, right? So bit k. So bits. This is 1. Then mask 1, mask. In the case num_t, and then mask equal and then yeah. Interesting. This interesting. Okay, I think this is it. Bye.